Hello everybody, it's Miss Sinclair. Hope you're all doing well. We're going to start a new unit called exponential functions. So we've talked about some other functions. We've talked about linear functions, which are a line. They're always in the form y equals mx plus b. And we've talked a lot about quadratic functions, and we know that those are x squared. That's kind of like when we see the x squared, we know that it's a quadratic. And that graph is a parabola. Kind of looks like a U. Okay, and today we're going to talk about exponential functions. And exponential functions always have a number raised to the x. So right here it has the form y equals a parenthesis b to the x. There's an example down below, 4 parenthesis 2 to the x. It always has that raised to the x. That shows that it's an exponential function. Just like an x squared shows that it's a quadratic function, something raised to the x shows that it's exponential. Okay, and we're going to talk about two types of exponential functions. We're going to talk about growth and we're going to talk about decay. So we can have exponential growth or we can have exponential decay. So an exponential function has this form, y equals a parenthesis b to the x. And it's just in the math world, they use the a and the b just to show that that's the form. A is the y-intercept or the initial value, and b is the base. That's why I guess they use a b, or we a lot of times call it the multiplying factor. And we're going to do some examples together so you can kind of see what it looks like, the form that it always takes. Okay, when b is greater than 1, it's growth. When b is between 0 and 1, I always say, just to kind of make it easier, I say it's less than 1, which it is, but it really is between 0 and 1. It's decay. So let's look at the examples and we'll get a good understanding of it. So the first one says y equals 4 parenthesis 2 to the x. Okay. I want us to take a look at the number inside the parenthesis. If that number is greater than 1, it is growth. So is 2 greater than 1? Yes. So it is exponential growth. Okay, and we can actually tell that it's growth in 3 different ways. So we can tell it's growth by looking at the number in the parenthesis. If it's greater than 1, it's growth. We could tell it's growth by looking at the table. As the x values are getting bigger, so as my x's are getting bigger on this side, what's happening to my y's? Are my y's getting bigger? Yeah, they are. 1 to 2, 2 to 4, 4 to 8, 8 to 16, they're getting bigger. So that's showing growth. And the third way that it's showing growth is the shape of the graph. The graph is increasing. Exponential growth graphs always kind of look about the same. They always look like this. They have an up arrow at the end. The graph is increasing. So it is growth. Okay? So that's 3 ways to tell that it's growth. And knowing that it's growth goes right along with what the multiplying factor is. The multiplying factor is just the number in the parentheses. So the multiplying factor is 2. What that means is if I look at my y's, how do I get from 0.5 to 1? Multiply by 2. Or 1 to 2. 2 to 4. 4 to 8. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. That's why we say the multiplying factor is 2. I'm multiplying by 2 every time to get to the next y. Okay, and then the initial value or the y-intercept. I can also tell what that is in 3 different ways. It's the number in front of the parenthesis. So the y-intercept is 4. See it right there, the number in front of the parenthesis. The other way I can see is look at the table. Remember, your y-intercept, I'm going to write this little note for you here, is when x equals 0. Because I want to look at my graph and I want to look at the y-axis. Where does the graph cross through the y-axis? Right here at 0, 4. So the y-intercept is 4. We look at the graph where it crosses through the y-axis. So for the y-intercept, you can just write 4. You can write 0, 4, but really how we typically write it is y equals whatever it is, y equals 4. If you want to write it as an ordered pair, 0, 4, that's okay. But again, typically we see it as y equals 4. Okay, let's take a look at the next one. 4 parentheses 1/2 to the x. First thing I want us to ask ourselves is it growth or is it decay? Well, let's look at the number in the parentheses. I have 1/2. Is 1/2 greater than 1? No, right? 1/2 is not greater than 1. It's less than 1. It's between 0 and 1, which is really what I'm looking for. So I know that it is decay. And just like you can tell growth 3 ways, you can tell decay 3 ways. Look at the number in the parentheses. It's less than 1. Let's take a look at our y values in our table. The numbers are going down. 32, 16, 8, 4, those numbers are going down. That shows decay. And then if I look at my graph, the graph is decreasing all the time and ends with an arrow going down. So I know that it is decay. Okay, the multiplying factor goes right along with growth or decay. The multiplying factor is the number in the parentheses, so it is 1/2. If I look at my table, 32 times 1/2 is 16. 16 times 1/2 is 8. 8 times 1/2 is 4. 4 times 1/2 is 2, and so on. That's why it's called the multiplying factor. What am I multiplying by to get from 32 to 16 or 16 to 8? I'm multiplying by 1/2. Okay, and then the initial value, the y-intercept, that's the number in front of the parenthesis. So that's 4. So I can look at it, I know it's 4. I could look at the table and see that the point is 0, 4. When x is 0, what is y? Or I can look on the graph and see right there, what happens, where does the graph cross the y-axis? It crosses through at 0, 4. So again, you can write 0, 4 for your y-intercept. That's okay, but we typically write it as y equals 4, just showing what our y-intercept is. Our y-intercept is 4. Okay, take a look at number 3. Do you think that's growth or decay? It is going to be growth, because if I look at the number in the parentheses, it is greater than 1. If it's greater than 1, it is growth. Okay, so again, I can tell growth in 3 different ways. I can look at the number in the parentheses. If it's bigger than 1, it's growth. I can look at the table as my x's are getting larger. What's happening to my y's? These numbers are a little harder to see maybe because they're not whole numbers, but these numbers are getting larger. They're being multiplied by 3 every time. 1/2 times 3 is 3/2. 3/2 times 3 is 9/2. And the other way I can tell it's growth is by looking at the graph. An exponential growth graph looks like this. That's showing me that it's growth. I have an up arrow at the end and showing me that it's growth. So the multiplying factor is that number in the parentheses, 3. Okay, and then we can get the y-intercept or the initial value as 1/2. So usually we write it as y equals 1/2. It's the number in front of the parenthesis. Again, we can get that in 3 ways. Look at the equation. Look at the table. What happens when x is 0? When x is 0, y is 1/2. Or let's look at the graph itself. Where does it cross the y-axis? Right there. That is 0, 1/2. Doesn't quite make it to 1. It's right in between 0 and 1. So 0, 1/2. All right, let's take a look at number 4. I want to look at the number in the parenthesis to decide if it's growth or decay. What do you think? Okay, it is less than 1, so it is decay. 1/2 is less than 1. So I actually know right away that my multiplying factor is 1/2. I just want you to see the 3 different ways that I can see that it's decay. I can look at the y's. As I go down in my table, as my x's are getting bigger, my y's are getting smaller. 80 to 40, 40 to 20, 20 to 10. Those are getting smaller, and they are being multiplied by 1/2. 80 times 1/2 is 40, 40 times 1/2 is 20, 20 times 1/2 is 10, and so on. Or I can look at the graph itself. Exponential decay graphs look like this, what I just drew. This is what a decay graph looks like. It is decreasing the whole time. It has a down arrow at the end. Okay. Now let's find the y-intercept, 5. So again, we usually write it as y equals 5, but really it's the point 0, 5. When x is 0, what is y? When x is 0, y is 5. Let's look at our graph. Here it is. Here it crosses the y-axis. Where does that red graph cross the y-axis? At 0, 5. So as I've said, it's fine to write it as 0, 5, but typically, for whatever reason, we usually write it as a y equals whatever it is. So y equals 5. Okay, why don't you try example number 5? Just tell me, is it growth or decay, and find the initial value and the multiplying factor. Pause the video for a few seconds and come back when you're ready with those 3 things. Okay, so if I look here, I'm looking at the number in the parenthesis. That's a 2. That is bigger than 1, so it is growth. That means my multiplying factor is 2. If I look at the table, my y values are certainly getting bigger, and they are being multiplied by 2. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. I can look at any part of the table. I tend to just look at what is the easiest part. I started at the 5. There were no decimals there. Okay, and then I can look at the graph. The graph does look like an exponential growth. It's increasing the whole time. There is an up arrow at the end. Remember, exponential growth graphs look like that. Okay, and then my initial value, or my y-intercept, is 5. So we'll write that as y equals 5. We're done, but just as a little more explanation, 0, 5 on my table, or let's look at the graph. Where does it cross the y-axis? Well, it crosses the y-axis at 0, 5. Okay. Why don't you do 6 and 7 and 8? And when you're ready, come back. So pause, do 6, 7, and 8, and come back when you're ready. Okay, so in 6, it is decay. The multiplying factor is less than 1. It's 1/2. 1/2 is less than 1. I can look at my y values. They are going down, so that's decay. And my graph looks like a decay graph, so I know that it's decay. My initial value, again, that's the same thing as your y-intercept, is 2. So we usually write that as y equals 2. Look at the table. When x is 0, what is y? That's what the y-intercept is. 2. When x is 0, y is 2. And let's zoom in on the graph. Right here, it crosses the y-axis at 2, 0, 2. So again, my initial value is 2, 0, 2, or y equals 2 is how we usually write it. Okay, in number 7, 2 times 3 to the x. That 3 inside the parentheses tells me that it is growth. When I look at my table, my y values are getting larger. 2, 6, 18, 54, 162. They're getting larger. And I'm multiplying by 3. That's why we call the multiplying factor is a 3. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. And we know it's growth because it looks like a growth shape. We know that the exponential growth graphs look like that. Okay, my initial value, my y-intercept is 2. 0, 2. When x is 0, y is 2. I could see that right here on the graph. So I will write my initial value, same as the y-intercept, as y equals 2. Okay, and then the last one like these. 1/4. 1/4 is less than 1, so I know that it is a decay. Okay. We can look at the y's, the y values. These are a little harder to tell, but these y values are going down. So that's showing its decay. And then my graph itself is going down. It's decreasing the whole time. It has a down arrow at the end. So that's showing that it's decay. So my multiplying factor is 1/4. So when my multiplying factor is less than 1, I know that it is decay. Okay, and then let's look at the initial value, or the y-intercept. That's 1/2. Goes right along with the table. When I look at the table, 0, 1/2. When x is 0, what is y? 1/2. Or let's zoom in. This graph's a little trickier to see just because of the scale, but this box, this line I just made is 2, so halfway would be 1. And if you look at your graph, it's really halfway between 0 and 1. So it's 0, 1/2. So my initial value is y equals 1/2. Okay, so now let's just kind of do a little summary. Increasing versus decreasing. So we have, here's our general form, a times b to the x. Increasing means that it is a growth. Okay, it has this general shape like this. The graph will kind of look like that every time. And it will increase if, I'm going to write it in words, b is greater than 1. Okay, you might see it like this, b is greater than 1, or I wrote it out in words for you. It is decay, decrease. Decrease means decay. Remember, the decay graphs look like this. And it will decrease if b is between 0 and 1. So you'll see it like this, but I know that can be a little tricky, a little confusing with the notation. But what that means is that b is between 0 and 1. Okay, I have a few more problems to do with you. So number 9 says, which of the following functions would best describe the data in the table? So we can do this the non-calculator way or the calculator way. I actually like the calculator way, but let's talk about how to do it non-calculator. Let's look at the table. If I look at 0, 2, that means that my y-intercept is 2. Choice 1 and 2 are lines. Choice 3 and 4 are exponentials. But let's take a look. My y's are going from 2 to 10, 10 to 50, 50 to 250. They're being multiplied by 5 every time. So when you're being multiplied by something, I'm showing that that is exponential. Exponential growth or exponential decay. This is going to be exponential growth because I'm multiplying by 5. My initial value, or my y-intercept, is 2, and I'm multiplying by 5. So that's going to be choice 4. But if we want to do it using the calculator, I think that that might be a good idea so we can see what it would be. So if we go to our calculator, we can try each choice and look at the table to see if it matches up. So the first choice is 10x plus 2. So let's go to the y equals 10x plus 2. And then let's go to the table. 0, 2, 1, 12. I don't believe that's what we're looking for. 0, 2, 1, 10. So no good on choice 1. Let's type in choice 2. 8x plus 2. And then let's go to the table. I'm going to clear that out. 8x plus 2. And then let's go to the table. 0, 2, 110, 218. I'm looking at the table. 0, 2, 110, 218. 0, 2, 110, 250. No good. It's got to match all of them. 2 is no good. So let's try 5 parenthesis 2 to the x. Okay. 0, 5, 110. Oh, right away it's not right. 0, 5. I'm looking for 0, 2. So that one's no good. And then we know 4 is the right answer, but let's look at it. 2 parenthesis 5 to the x. Zero, 2, 110, 250, 3, 250. If we look back, we see that all our whole table matches, so it's choice 4. Okay. 10 is just like we did in 1 through 8. I just want you to state the y-intercept and whether it's exponential growth or exponential decay. So again, why don't you pause for however long it takes you to do those few things, and then come back when you're ready. Okay, so the y-intercept is the number in front of the parentheses. So this is y equals 8. And I know that it is decay. It is decay because the number in the parenthesis is less than 1, 2/3 less than 1. So it's decay. Okay, the second one, the y-intercept, is 125. This crosses the y-axis not until 125. And I know that this is growth. And the reason I know it's growth is because the number in the parenthesis is greater than 1. 1.5 is greater than 1. Okay, see the y-intercept is 56. So y equals 56. This crosses the y-axis at 56. This one might be a little bit tricky. I have 3 over 2. Well, 3 over 2 is 1.5, so this is growth. They chose to write the 1.5 as a fraction, whereas in B, they chose to write it as a decimal. So I could have rewritten C as P of T equals 56 parenthesis 1.5 to the x. Same thing. If you're not sure about 3 over 2, if you're ever not sure about a fraction, just put it into your calculator. So just do 3 divided by 2, and you see that it is 1.5. So 1.5 greater than 1. Okay, 2 more. 11, this is a word problem. It says the breakdown of a sample of a chemical compound. So like something like an atom, not an atom, but like a compound we find in science, is represented by the function f of x equals 100 parenthesis 0.3 to the x, where f of x represents the number of milligrams of the substance and x represents the time in years. It's breaking down. In the function, explain what 0.3 and 100 represent. Well, 100, as we know, is our y-intercept. So when we're talking about word problems, you can write that it's the y-intercept, but what typically it is we'd say 100 is the initial amount in milligrams of the substance. Okay, so the scientist initially had 100 milligrams of the substance. And then the 0.3 is at what we call the multiplying factor. Okay. Then in number 12, we can do 12 just like 9, where we can put them into the y equals and then look at, instead of looking at the tables, we can look at the graphs themselves to see which one matches. But let's see if we can figure it out without the calculator. Is this growth or is this decay? This is decay because the graph is going down, right? Decay. So let's look at the choices and see if we can eliminate any. Well, we know it's growth or decay based on the multiplying factor. So here's the multiplying factors. 1.25 is greater than 1. That's out because it needs to be less than 1 to be decay. 1.04, that's out because it needs to be less than 1 to be decay. 1.04 is greater than 1. So we left with choice 2 and choice 4, 0.75, that's less than 1, and 0.45, that's less than 1. So those are both good. And then let's look at our y-intercept. The y-intercept is where it crosses the y-axis. Crosses the y-axis right here. I mean, it's hard to tell an exact number, but it's somewhere between 10 and 20. A little higher than halfway, so it'd be greater than 15. If we look at our choices, is the y-intercept 18 or is the y-intercept 40? Well, it's definitely going to be 18. It's below 20. 18 is the only number out of my choices that are below 20. Okay, and we don't have to write an explanation because we just talked about it. Okay, everybody, have a good rest of the day. Bye.